Hello, my name is Andrew Grant, and in this video, one of a small series of videos looking at C++ modules, linked to the series in the description, we'll be looking at using the VC Package Manager with C++ modules. As with the previous videos, we'll be using Visual Studio 2022, the latest version on Windows 11. Before you can use the VC Package Manager, you must make sure that the capabilities are installed in your Visual Studio installation. Start up the installer for Visual Studio and search for it in the Individual Components tab, and enable it if required. Once you have the capability installed, fire up Visual Studio as an administrator and click on the Continue Without Code text. Once you get to the workspace, open up a terminal within Visual Studio and tap in vcpkg integrate install and press enter. This will activate VC Package, making it available to all projects. You may get a lot more text scrolling along than is shown here, but once VC Package is sorted, just exit out of Visual Studio. Now fire up Visual Studio as an ordinary user and create a simple C++ console project. Make sure to set the language standard to the latest and the scan sources for module dependencies to yes. This is for all configurations. Okay, so you've got VC Package installed, but to use it you have to tell Visual Studio to use a thing called a VC Package Manifest. So head over to the project properties and in the VC Package tab, change Use VC Package Manifest to yes. Click Apply and OK. Now we will create the manifest. So add a new file to the root of the project solution and give it the identifier all lowercase vcpkg.json, just as you see on the screen. Now open up the newly created vcpkg.json file and using the usual JSON syntax, tap in the name of the application. Please do bear in mind that it has to be all lowercase, no spaces or special characters. Then the version string. Set this to 0.1. If you add any more packages or whatever, you can update the version as appropriate. And follow this with the dependencies. These are the packages or package that you want to install. In our case, it's going to be the rather excellent Pkg XML library. And then just save the file. Once you've created the manifest, you need to load it when compiling. And as this is Visual Studio, we should be able to easily automate this process. In the project properties, making sure you're in all configurations, head down to the build events, then the pre-build event. In the edit section, write out the following. Set file equal $SolutionDir in parentheses, vcpkg.json, 2 spaces at the end of that statement. Go down 2 lines, and then if exist, %file %, open parentheses, and then 2 spaces, down a line, and then the double quote $, vcpkgRoot in parentheses, /vcpkg.exe, close double quote, space, x-update-baseline, space, double dash, add dash, initial dash, baseline, and 2 spaces at the end of that line. Open the double quotes, down a line should I say, open the double quotes, $, vcpkgRoot in parentheses, /vcpkg.exe, close the double quote, space, double dash, triplet, space, x64-windows, space, install, and 2 spaces at the end of this line. Down a line, close parentheses, and again 2 spaces. I'll add that you should make sure there are 2 spaces at the end of each line, and that there's an empty line between the first line and the if statement line. This is quite important, as you may encounter some rather obscure, and I'm not going to say difficult, errors with some of the most vague, incomprehensible and erroneous error messages you'll ever encounter. I'll pop a copy of the text in the description. Not too sure if the YouTube verification system won't remove the empty spaces at the end of each line. So just to be sure, make sure they're present after you do a copy and a paste. And once you've got that done, click OK. This is the text you write into the command line dialog. I'll leave it up for a few seconds, so you can pause the video and write it down if you wish. But don't forget there'll be a copy of the text in the description. The important bit is don't forget the 2 spaces at the end of each line. and the empty line after the first line. Now jump over to the entry file and create an empty entry function. If you want to see a bit of magic, open the vcpkg.json file and watch the joys of automation. Compile the project in debug, and the built-in baseline should be automatically added. It's rather fantastic. And now compile the project in release mode as well. The baseline doesn't change, thank goodness. Makes maintenance a tad easier. And don't touch this line, ever. Let the system handle it for you. This is the XML file we'll be using to verify VcPkg works. It's a bit basic and all that, but it's quite suffice for our current purposes. This is the important file within the project, the process xml.exe module. It's the one in which we utilize the PkgXML capabilities. As PkgXML doesn't support modules, we have to do the traditional hash include and the relevant header file. This means that we first declare this file, the process xml.exe, as a module, but no identifier is presented just yet. And then we hash include the relevant header file, pkgxml.hpp, and then we can do the usual export module identifier. Everything else is as you would expect from a module. All the other modules you see in the project are quite literally just there providing the necessary support services for this module. However, if you want to have a peer at the whole project, a link to the GitHub repository is in the description. You can, if you wish, have a peer at the PkgXML header file. Just pop your cursor over the file name and press F12, or right click on the name and use the option within the submenu. And here we have the pkgxml.hpp file. It's really quite fascinating, well worth a look, and had some very interesting code that you could use to enhance your own knowledge and skills. And if you're curious, once you're in the header file, if you right click on the tab, you can go and have a look at where the header file is located, that is, was installed within the project. You can see it's held within the project in the vcpkg install folder. This is the usual place for the vcpkg header files. And here we have another important file. Whilst this file doesn't use the PkgXML capabilities directly, remove them and you'll experience a series of errors that quite literally make no sense. It's the sort of thing you have to be on the lookout for. I don't find it often, but occasionally you do. In this case, it's down to the fact that the XML parse result and the XML document variables are not real. Not like an integer or a double, but they're real in the sense that they're available for the relevant code to access. You probably have to rely on a bit of trial and error when you come across these sorts of scenarios. You will see under the function names an underlining of the name with tiny dots. Hover over and it'll tell you to make this function static. See, here is an example of the error you get if you do make the function static. Modules don't play very well with static functions. They don't have to. Anything in a module is contained within the container, the module, and a static descriptor just upsets the apple cart. It's not needed. So all that, compile the application in both debug and release modes, run it, and you should get the XML data displayed in the terminal. We'll finish at this point. It was a very quick look at the current methodology for including external projects in a C++ project using modules on vcpkg. Thank you, and I'll see you in the next video.